In question 9 in 2024, we're dealing with a sphere and a radius of r. Part of the sphere that is cut off by a flat surface is called a cap. So here we have it here, flat surface. So that's going to be a hemisphere. Or part of a sphere. It's not a hemisphere because it's not half, but it will be the same formula for volume. So here C is the volume of the cap, and we're given this expression, and we're told that K is less than R. We're told R is 13, K is 4. So it's just substitution for the first part. C is equal to pi times K squared, which is 16, divided by 3 times 3 times R, which is 13, minus K, which is 4. So this is going to give 39 minus 4, 35 by 16. And my calculator is given it as 186.67, so 186 and 2/3 pi cm cubed, or units cubed. It's units, I think. I don't think they deal in cm here. Units cubed. And in terms of pi, we've left pi in the question. So part 2. Different sphere of radius 8 and a cap with height y. And we're told the volume of this cap is 36 pi y. Use this expression to show that this is true. So 36 pi y is equal to the volume of the cap, which was given above as pi k squared over 3 times 3r minus k. Just double check, 3r minus k. So in this case, we're told that the height is y, so that's my k. So that's going to be pi y squared over 3. And the sphere radius is 8, so we have 24 minus y in here, 3/8. So 36 pi y is equal to this expression. So we divide by, we want 36 on its own, so divide by pi times y will be pi and one of the y's over here. So we'd end up with 36 is equal to y over 3 times 24 minus y, which is what they were looking for. Then we're asked to multiply this expression out. So 3 36s is 108. That's equal to 24y minus y squared. So y squared minus 24y plus 108 is equal to 0. The factors are 108. 24, 6, 18. 6 and 18 is 24, 60 and 48 is 108. Okay, so y minus 6 by y minus 18 are my factors. So y is equal to 6 or 18. So why we got two values? Because they gave us this information here that y is between 0 and 8. So y has to be 6 units or centimeters. Did they give us centimeters? No. A hemisphere of diameter x, in this case. The volume of this hemisphere is given by this expression. Find the value of x when the volume of the hemisphere is 3. So it's in centimeters cubed here. This might have caught a few people out. So 3 liters is 3000 cm cubed. So pi over 12 x cubed is equal to the volume 3000. So pi x cubed is equal to 36,000. Dividing by pi, we get x cubed to be 36,000 over pi. So I need the cube root of 36,000 over pi to get x on its own. That's giving me 22.54 centimeters. To one decimal place would be 22.5 centimeters. Part D, the volume is increasing at a constant rate of 450 centimeters cubed per second. So volume and time, so volume over time, volume increasing at a rate, dv dt is volume over time, 450. And we want to find the rate at which the diameter is increasing. So the diameter is x, so we're looking for dx dt. creating my chain rule, what I already have, dx dt is equal to dv dt times, we want dx dt, so there's my dx dt, so dx dv, and we have v here in terms of x. So in volume is equal to pi x cubed over 12 dv dx is equal to 3 times pi x squared over 12, which is equal to pi x squared over 4. So that's dv dx. We want dx dv, so we sub it in here. We're going to get dx dt is equal to dv dt, which is the 450, times, and we're told that x is 20, so it's going to be times the inverted one of these. So we turn it upside down, 4 over pi times 20 squared. So that's 450 times 4, which is 1800 over 400 pi. And that's going to give it 1.43. And we want it in centimeters per second, corrected 1 decimal places, so 1.4 centimeters per second for the rate of change here. In part E, we have a cone of radius r and height h. The curved surface area is given by this expression. It's just manipulation of formula, rearranged to write h in terms of, so h equals, we want h equals. Where's my h? It's inside, so I've got to divide by pi r. Just do it one step at a time. Equals r squared plus h squared. Square on both sides, I get s squared over pi squared r squared is equal to r squared plus h squared. So s squared over pi squared r squared minus r squared is equal to h squared. If I simplify these as one fraction, I'm going to get s squared minus pi squared r squared by r squared over pi squared r squared times 1, just pi squared r squared. This will be equal to h squared. And if I get the square root of this, I'm going to get h. So h is equal to, now I think you can see the way they want it looking. They want a square root on top and no square root on the bottom here. So I have my top s squared minus pi squared r to the power 4. And the square root of these pi squared r squared is just pi r. So h is equal to this expression here.